Welcome to Math YouTube channel. In this class, I am explaining about geometrical interpretation of derivatives. What is geometrical interpretation? Very important. What is geometrical? Nothing but the geometrical form. Geometrical form contains so many. Those are square, rectangle, curves, tetrahedron, sphere, circle, so many. But some of them are discussing in this class. See here, first of all we want to know about the derivatives. Already you know about derivatives. Differentiation. Nothing but a differentiation. That is first order differentiation, second differentiation. You know that. But why these derivatives are used in curves? Why these derivatives are used in geometrical interpretation, geometrical formation? Means these are used for finding slope, for finding length. So in this way, these derivatives are so many uses, so many useful things which are used in geometrical formation. So dear guys, see here, tangent, secant and normal. What is a tangent? Already you know in the lower classes. What is by tangent? But here we are discussing in some different way. Okay? So see about tangent. What is meant by tangent? Tangent. Tangent is nothing but a line. Yes, simply it is a line. But which type of line? All are lines. But which type of line? Secant is also a line. Which type of line? Normal is also a line. Which type of line? That is different which you have to observe carefully. That is important point which you have to catch it in this class. Okay? So, normally a circle containing tangents, a curve containing a tangent. Take a curve. This is a curve. Now, this is a point P. For example, this is a curve. This is curve. This is a point P. Suppose that point contains coordinates as A, B. A is first coordinate, B is second coordinates. Okay. Now, there is another point near to B, neighbor to B. Can take another point, some here. On the curve. Another point to Q also on the curve. Now join these two points. So this is called what? This is called secant. This is called secant. So joining the points P and Q is called a secant, which is going through P, also Q. This type of line is called secant. But what is tangent? See here, please observe carefully. Take another curve, same curve. Suppose this is a point P. Here this is a point Q. This point Q want reaches P means that point definitely goes through curve. This point Q want reaches P means that point definitely goes this path only. That path is curve. Yes or not? That point didn't go another way, another path, but definitely that will go through the path to reach P. That means the line goes through this one, through the point. But here this Q moves to step by step near to P. This is a curve. This curve touching the line at P. This is called a tangent. Another tangent is also there. But see here, this point Q goes to near to P through curve touching the curve, through the curve, via curve, that point is called, that touching point is called, whenever the line goes to the touching point is called a tangent. So this type of lines is called a tangent. This is also a tangent. Okay? So see here, please observe here, what is the difference between tangent and a secant? This is a tangent. What is the difference between tangent and a secant? Please observe carefully. Secant is nothing but the line passes through 2 points, P and Q. P is near to Q. That is some kilometers or meters or centimeters, whatever it may be. Leave it about that. But there is a point Q is there near to P. That point and P reach a coincidence through these 2 points is called secant. But tangent is different from secant. Why? Because tangent touches this curve only at one point, that is P. That is P. At one point, whatever it may be, that is Q. Q reaches to P in the path of curve, and the path of curve through the curve goes to this way, in this way. But suppose if Q goes to here, the touching point is this. Whenever the line goes through this touching point is called a tangent. But what is tangent? Tangent contains only one touching point on the curve, on the circle. But secant contains 2 touching points on the curve. That's the difference between secant and a tangent. So there are so many tangents containing curve. Okay. Next comes to normal. Suppose take another curve. There is a point P, and the tangent goes through the curve, touching at the point P. A line passing through P, normal to the curve. A line passing through P, normal to the curve, is called normal to the tangent. That is normal line, normal to the tangent or normal to the curve. So this is normal line. This is normal line. Okay? So please observe carefully. The line passes through the point P, touches the curve, and normal to the tangent is called normal line. That is, it makes an angle of 90 degrees. See here, 90 degrees. Here 90 degrees. Totally 360. So this type of line is called normal line. Okay? So see guys, what difference between secant, tangent and normal line? Please observe carefully. Secant is nothing but the line passes through 2 points P and Q. Tangent nothing but passes through P, touching at curve. And normal line is nothing but which is normal to the tangent through the point P at the curve. Okay? These are 3 differences between tangent, secant and normal. Now, what is the equation of a tangent? Okay? See guys, now equation of tangent. What is the equation? It's nothing but equate 2 expressions, which is equating 2 expressions. That's nothing but a equation. Okay. Equate tangent. Suppose where tangent on the curve. Without curve there is no tangent. Without circle there is no tangent. Yes or not? So let y is equal to f of x be a curve. For example, this is a curve. This is y equals to f of x. This is equation of curve. Now, which is passes through point P, contains coordinates as a, b. Now, and P be a point on the curve. What is P coordinates? a comma b, whatever it is, xy a comma b, whatever it is. Okay, this is xy, f of x is a curve equation, and p of a b is a point on curve. Now, what is the tangent equation? What is the equation of tangent? How to find? Means, for example, y equals to f of x. Y equal to f of x. Therefore, slope m of a tangent at P, at point P is m equals to f dash a equals to dy by dx at a comma b. This is slope of a line. You know slope of a line and a point P. What is the formula for equation? And having a slope, a line containing point P, having coordinates x1, y1, and having a slope m is y minus y1 equal to m into x minus x1. So these are already I told in last classes in coordinate geometry. If you want to check those videos, okay. So the line containing a slope and having a point P, slope point P is y minus y1 means b equals to m means f dash a, x minus a, x minus x means a. This is the tangent equation. Therefore, equation of tangent is y minus b equals to f dash a, x minus a. That's all. This is the equation of tangent. See here. Now equation of normal. Normal means already told now. This is a curve. This is a point P. This y is equal to f of x is a curve, equation of the curve. This is a, b. Now slope of tangent to the curve at P AB is f dash a. Already I told now. This is slope of tangent to the curve y is equal to f of x. This is curve. At P is f dash a. Okay, this is slope. Now take a line normal to the curve and passing through P, which is normal to the tangent. This is normal line. That means which is perpendicular to tangent. Is or not? Perpendicular to tangent. So therefore slope of normal equals to minus 1 by f dash a. You know that. Already told in the coordinate geometry. What is slope of perpendicular line? So minus 1 by f dash a. This is the slope of the normal line. Now you know about slope of normal line and which is passing through point P. Therefore equation of normal equal is x minus a. That's all. This is this equation of normal, where f dash a not equal to 0. This is the condition where f dash a not equals to 0. So see guys, you know about equation of tangent and equation of normal and secant. These are very important derivatives. Those in equation of derivatives, please practice these equations and formulas. Okay guys, thanks for watching. If you like this video, please subscribe, like and share it. Thank you.